Shape. Okay, everybody can see the PowerPoint. Everybody can see the PowerPoint, please.
Yes.
Okay, that's good.
Yes.
I'll be using my mouse as a pen, and then I'll be using the annotation of the WebEx. Now we talked about this, but then about the states conversion from solid to liquid, liquid to gas, and vice versa. But for some reasons, then the power went out. So now we can go and look at the matter itself. Not, I mean, the state of matter, solid, liquid, and gas. But the conversion, we covered that. So, but now the classification of a matter itself, as you can see from the PowerPoint. Well, it turns out to be, if you look at this, we can have the picture here. So the matter is whatever we say that matter is whatever is what anything has mass and occupies space. I mean, it has a value. So matter value. So the matter itself here, if you look, matter itself here can go to two main branches, pure substance and the mixture. And always you see the mixture is coming from the pure substance, and it can go back to pure matter itself. So a pure substance is a matter having fixed composition. Any pure substance is considered a pure substance that has really a fixed composition that's not really changed by location or any other conditions. So such as, I'll give you an example, H2O. This is a pure substance, correct? Of two hydrogens and one oxygen. Correct, guys? So now, if I'm in this galaxy, the Milky Way galaxy, or I'm in another galaxy and I find H2O, this has to be two hydrogens to one atom. It's still, this is composition. It's not changing by location, by position, by anything conditions, such as pressure, temperature, nothing. Still two hydrogens to one oxygen. That will make a pure substance called H2O or tap water. So that's the definition of the pure substance. Now, if you mix those pure substances, you have the opportunity to have mixtures. And the mixture themselves, they can differentiate in two types of mixtures, homogeneous mixtures and heterogeneous. So heterogeneous mixtures and heterogeneous mixtures. So what is the difference between the mixtures here? So now we have a mixture here, combination of pure substances, and they go heterogeneous, or they can go homogeneous. Now, really, the difference between them is very, very obvious, because heterogeneous means you can see two layers. So the distribution of the pure substances within the whole container is not distributed formally. So you will see, you can distinguish those pure substances. one from each other, so you can really see the distinct two layers between mixture solutions. So homogeneous, the distribution is uniform. You cannot distinguish between how many pure substances inside. It's just one single layer, and that's the difference. Now, the mixture themselves, whether heterogeneous or homogeneous, can separated here, can go back to pure substances by many means, by physical means. So here it is. You are combining, they go this way to mixture pure substances, but you can separate the mixture back to their original pure substances by filtration, by distillation, by decanting, by vacuum, they call it vacuum distillation, and this is a normal distillation. By, I mean, it's just too many ways and methods, physical methods to separate those mixtures to their pure substances. Okay, guys. Now we'll come back and look at the pure substances, and as mentioned here, of elements like H2O. It's two atoms of hydrogen to one atom of oxygen. So I mentioned this indirect, show you that the pure substance itself is a combination of more than one element, combination of more than one element. That's we call it to make this. And so the elements is really, it's this unit of pure substance which cannot be destroyed chemically. So if I have an element such as hydrogen, I cannot destroy this element hydrogen physically by physical method. Physical method means filtration, distillation, vacuum distillation, decanting, magnetic gravitational forces, gravimetry, calorimetry. All those physical methods cannot separate hydrogen, cannot break hydrogen. But when I say by physical means, I can really, chemically I cannot destroy it, but chemical means I can destroy it, such as I have a nuclear destruction of hydrogen. And then when I destruct hydrogen or oxygen, matter of fact, then I get to the bottom of the least, the smallest ever part of this element is called an atom. So from here, okay, so I have an atom. That's not there. I don't know why it's not there. They should have really. The element is really made of an atoms, correct? And the atom, then I can even break this atom further, and I get protons. I can get protons, B plus. I get neutrons, no charge. And I can get electrons. Those electrons are well, within this atom itself. So I can break the atom into three species, correct? Proton, neutrons, and electron. Electrons are negative charge, protons are positive charge, and neutrons, from the word neutron, they are neutral. Neutrons are neutral, that's the word it came from, and they have no charge on them. So that's the element. Now, if I combine those elements, see, I make a pure substance, which is really called compound. But this compound has to have fixed composition ratio, cannot be different every time. So that's a difference. See? And This is very important. So this is compound now. It's a combination of more than one element. So elements will bring you to this way, to the compound. Now we have a compound, and sometimes we produce something called molecule. So there is a difference between compound and molecule. Somebody will tell me what's the difference between this, unmute yourself, and tell me what's the difference between molecule and compound. Hello, everybody? Hello? Somebody can hear me?
A compound has two or more elements, and the element is just like one.
Yeah, you are very close to the answer. The molecule and the compounds, they are really exchangeable. We exchange their definitions, but there is distinct difference between them. Uh, the molecule is the least ratio of the element within this, within this compound, or within a compound, within a pure substance. The least. I can give you an example here. So here it is. If the ratio is the smallest ratio, then I say, okay, this is a molecule, such as nitrogen N2. Nitrogen made of two nitrogens together. So if you look, this is nitrogen here, triple bond. This is two sets of lone pairs of electrons. So this is nitrogen 1-to-1 ratio. There is no nitrogen N3. Wherever you go in the galaxies in this universe or anywhere in the universe, nitrogen is not N3, N2. And this ratio is between the elements is 1-to-1. Same element, but it's still 1-to-1, the smallest ratio. Now I can give you an example here. I have, for example, O3, okay, B or B2, sorry, B2, O5, okay, said B2, B2, O5, O10. Now, as I see, those ratios, relatively small ratio within the, of the element within the compound. You can see there's 2 to 3 in the first one, and then 2 to 5 in the rest one. But how about before or 10? So we can tell about this ratio is very close. I mean, 2 to 3, 2 to 5, 2 to 4. This is a molecule, correct? So those compounds, smallest ratio, very close to each other, very small. However, you have P4 or 10, correct? And this ratio is very large. So this is compound. This is what? Compound. And this is called molecules. Can you see it? Those are called molecules. I apologize. I write with my what they call it, with my mouse. So Now we have the largest ratio between among the elements to make a pure substance. That's a compound. The smallest ratio ever, that's we call this is molecule. So diphosphorus, this one here, diphosphorus trioxide, diphosphorus pentoxide. Those are called molecules. But before tetraphosphorus decoxide, deca means 10, decoxide, this is large ratio, and this is called compound. In the same token, I can take this one here and say, how about those two here? Carbon monoxide, carbon dioxide. They are what? They are molecules, correct? The ratio is 1 to 1, 1 to 2 in the carbon dioxide. So 1 to 1 in carbon monoxide, 1 to 2 in carbon dioxide. So you can tell those are thought to be molecules. However, some textbook authors, they will exchange those, say carbon monoxide compound. So, but we know that's the by definition, molecules means the simplest, least ratio of the elements within a pure substance. So the least ratio. Okay, guys, so that's what it tells us how the matter is distributed to be a pure substance mixture, or what type of mixture we have, what type of pure substance we have, and then it goes to all the ways to atoms, which is the basic smallest unit ever and cannot be broken in the chemical reaction. Have to use a nuclear reaction. Chemical reaction will not break an atom. And if you break an atom, go further, then you can get to see all those protons, neutrons, and electrons. Protons and neutrons are inside the nucleus. Electrons is outside the nucleus itself. Nucleus is the center position or center place in the atom, which is hosting protons and neutrons. So, guys, any questions so far? Questions so far?
No.
Okay, now we go for.
I have something to say. I have problems hearing you, Dr. Atella. The volume is very low. I don't know if you can speak a little bit, raise your voice a little bit more. I'm sorry.
You can't hear me? Okay, I have the voices all the way to the. My voice is 100%. I put it on. So, and I'm very close to the try to raise the voice in your laptop or iPad so you can hear me very well. But my voice is not good because I caught some cold a couple of days ago. So, yeah, you can see here. This is the sound here. Indicators indicate 100%. So I'll try my best.
Thank you.
Okay, so so significant figures. Well, significant figures always expressing the uncertainty in a value. For example, I have a balance. We have tableau bat open to the air, which is less precise. Meaning, I mean, if you wear them a couple of times, you will see they are not really less precise because they are subjected to the outside condition, temperature, flow of air, humidity, and all stuff. The analytical balances, they are closed all over the places, glass, with the glass, and when you weigh anything inside them, they will give you better precision. So if you weigh second, third time, fourth time, the same object, you get number like before you have obtained. So the that's what we have. So if I say the tab load, tab load balance give us maximum weighing is 300 plus minus 0.5. So 0.5, 300, the decimal, and then 5. The 5 always in this balance, always a problem, because that's, I'm not certain, because every time I go and weigh anything to the max, it might give me 3.4, 5, 3.49. So there is uncertainty in the last digits of reading the balances, especially the tabla load one, the flat one, open to the air, open to the airflow, moisture, everything. So, and that's what really comes to the idea, is to learn about significant figures. So it looks like significant figures will depend on whole exact number from 1 to 9 and the zeros. So the rule is between the whole exact number, 1 to 9, and the zeros. So if I put for you a number like this, and I would like to know what will be, maybe I'll put a new let me put a new one here so we can follow. Hold on, yeah, we can follow this one here. I'm putting a blank piece of paper here or sheet. So then I'll put a number here. Then we have to determine what is the significant figures in this number here. Double 0, 0, row, decimal, 3, 1, 2, guys, 0, 1, 9, 6, 0, 0. How many significant figures does this value have? Somebody will tell me how many? How many, guys? Help, somebody will tell me.
13.
13.
9.
Okay, now we have 13, we have 9. Let's open an auction here, you know. I like auctions, but you can raise your hand. I'm not selling that you any price for that. So we have 13 and 9. Somebody else? Somebody else will go to this auction here. We have 9 and 13. Somebody will more or less?
9.
9 and 13. We'll see. Those zeros here for decorating. It's not allowing me to write very well, so. Those called decorating. Right, the mouse is very hard. Decorating. Those here called locating. Those are trapped. Substitute whole exact numbers here. That's this one is 1, and this is 2. Those trapped between number 2 and number 1. Then you have this one here. To come at the end of the value, ending zeros. So now those are here, those numbers here are exact whole number, exact whole number. And because they are exact number, they're always significant. Significant, okay? So the trapped one are always significant. Okay, here the decorating is not significant. Not. Why is it not significant? They are failing here. That whole number is missing. Exact missing. Okay, so they are not significant. The locating, not significant for the same reason. For the same reason. Because they are missing what? Whole number for them. So here it is, we are missing a whole number here before them. So, and the ending zeros, they have to meet two conditions at the same time. Two at the same time. What is those conditions are first at the same time, presence of the decimal in any place inside the value, presence of decimal, position of the value itself. So the decimal here, here's the decimal. Can you see it? This is the decimal, far away from the ending. So, but the condition is you have to have the decimal anywhere inside the value. We have the decimal here. The second is the of the exact whole number of exact whole number. So now since the whole number here is 6 and the decimal is present, they are significant. Right. The whole number is significant. The trapped one are always significant because they come between, they are, the beginning of them is you have whole number, all exact number, and the last number after them is all exact, not trapped. Exact number are significant, and those are not significant. It's not significant. So the answer is, how many now we have? How many significs we have now?
8.
8? No.
9.
9? No.
6.
No.
13.
The answer is 13, correct. Let's count them here. Let's count. 1, 2, 3, 4. Significant because they meet the two conditions. Decimal is present and the whole number, exact number is present. Decimal is far off, but it does not matter. It has to be within the value. It's present. It's present within the value. So those are 4, 5, 6, 7. The trap one, yes, all the time. 7. Okay. 9, 10, 11, 12, 13. So value here has 13 sig figs, guys. Guys, now let's do as I said, I'm recording, taking those notes here. It's within the recording here. So let me just stop the sharing and then go for the worksheet to see if we can solve some of the share the I'm sharing iCollege. Everybody can see iCollege? Everybody can see iCollege?
Yes.
Yes.
Okay, let's go for the folder area and look for worksheets. So we have worksheets are here. So significant figures. That's I think that might be Dave. Let's see. Now that's the significant figure we talked about. Dave. Power see here model 3 101. So worksheets, we have a worksheet for metric, we have English conversion, we have worksheet here. Let me just upload it for you. Okay, let's put some of the sig figs. There are plenty of those, and we need one without. They have a number there. So okay, guys. Can you see the PDF file, or I have to go and can you see the PDF file?
No.
I have to exit. Go for it. Now you can see the PDF file, correct? Okay, guys.
Yes.
Make it bigger. I'll make it bigger here. You can see it now. So the first value, you can tell me how many significance this one does it have?
5.
Everybody says 5. Everybody says 5. Okay, how about this one right here? 7, and you have 5 zeros. How many significance we have?
1.
1. Any correction?
6.
6. Any other value? We are between 1 and 6. Which one's correct?
6.
6 is correct? Well, the answer is 1. Why? Those ending zeros, they are missing what? They
A
are
decimal.
missing the decimal. You have to have 2 conditions. So if I put this one here now, five, and they put the decimal here, that's 6 now. This one here is 6. But this one here is 1 because the decimal is missing. You have to have both conditions at the same time. You have whole exact number and the decimal present. Okay. But this value missing the decimal, so it's 1. Those 5 zeros at the end, they are not significant. So how about this one now here? Just talk about it in a couple of minutes. How much is this?
5.
5. Any other value?
1.
Any other value?
4.
1. Which is the correct answer? Somebody knows what the correct answer is?
5.
The answer is 5. Why?
Because of the
No,
decimal.
we have the decimal is present, correct? Those zeros will come after the what? After whole number. The 2 conditions are met. Remember, the whole exact number will supersede priority of the decimal itself. So 1 is one significant figure, but now we have 2 conditions are met at the same time. So those zeros are significant, those 4 zeros. So the answer is 5 correct. Now how about this one on here? How many?
1.
Any other answer? Other answer?
4.
4. Any other answer? 1 and 4. Any answer? The answer is 1. Why? This first 0 before the decimal called what? For decoration, decorating 0. The one coming after for locating 0. Since they are missing here whole exact numbers, both decorating and locating 0 are not significant. So you are dealing with the whole exact numbers always significant. This is just 1. Okay, all those 4 zeros are not significant. Now, how about if I add here take this one out. I will add now. I will add here number 2. So how many significant zeros we have here? I mean,
6.
6. That's correct. Why 6? What we call those zeros here? We have ending zeros, locating zeros, decorating zeros, and
Trapped.
trap zeros. So what are those? The whole exact number will supersede power of the decimal or the roll of the decimal. So those are trapped because this is a whole number, exact whole number is 1, whole exact number is, and all those zeros are trapped. Remember, the decimal has the least to say. When it comes to priority, the whole exact number takes over. So those are trapped, not decorating or anything. Those are trapped between whole exact number, 2 and 1. So this one here will be then, the answer is 6. One number correct is significant. 2 is significant, those 2, and the 4 0 significant, 2 and 4 make this one 6. How about here now? How many?
4.
4.
4 is correct. Okay, so what else? How about you?
3.
3? The answer is correct, but why? Why is 3?
It's a decorating 0, and the 2 other zeros, they're just there. They're the finder zeros. They don't count.
Yeah, they don't count, but this 0, the last 0, ending 0 is counting. Why is this? It's very important.
It's a decimal.
Because the 2 conditions are met the same time. You have the decimal there. Here's the decimal, and you have whole number before it. So I think this one will be okay, unless you have any other questions. Any question about how about the last one here? How much?
6.
6 is correct. So you get the idea. Those what we call those 0 in here. What the name of them? How we can label them?
Trapped.
Trapped. Those are trapped between all 2 exact numbers. That's correct. Now, because we can go further on this and say, how about if I have 2 point, no, 10 power minus 5. How many suffix we have here? Here. How many? How many guys? Oh. Hello, everybody's here is with me?
Yes.
4.
Yes.
Okay, the answer is 4. That's correct. So anytime I have exponent negative or positive, they have nothing to do or to say with suffix. So this one has 4 suffix, correct? Time I have log, I have power. Those are not part of suffix. Those are the only one, and those are 4 significant figures, correct?
Correct.
Now let's do the same thing here. If I would say, let me take this one here and then take this 10 here and then say, okay, log of 2. How many significant figures you have here? How many? Well, it's still 4. It's still 4, meaning what? Meaning, again, we said the exponent, they have nothing to say. And we said the log have nothing to say. Still 4 significant figures. How about if I transform this one here into ln?
It's the same.
ln and 2. They're still 4 sig figs because they are not part of the sig figs. Okay? They are not part of the sig figs. You get the idea, guys? Get the idea? Okay, so we will look now at the application of the significant figure. Let's look at the significant figure applications. Let me just take this one out. The addition and subtraction, they have the same rules, and division and multiplication, they have the same similar rule or rules. So when you add or subtract, you get the value, the answer from the calculator, you put it there in front of you. And when you round to the correct significant figures, you have to consider the last digits. So the last digits of the after the decimal, the last digits after the decimal. That's for subtraction and addition. Now somebody will tell me how much is this, the value of those 3 here? How much is it? We'll do one of them. So somebody has the answer? Hello? Somebody has the answer? So if I will add the answer here, whatever the answer might be, I can do it in the calculator, but I don't want to lose time. There is a solution for that. So it is. So you can see the answer, guys. But that's not from the calculator. That's already give you the final answer. What's the final answer of this? Let's see. Just hold on. I'll put the answer here. 567 plus 100 plus 1.
Dr. Atiyah, can you explain it again?
Hold on.
Yes.
Here it is. I got the answer here. Hold on. I get the answer here using the calculator here, guys. Can you see the answer here? The answer is 196. I write it here, guys. The answer is 169.037. That's the answer, guys. That's the answer, correct? Now I come here and look how many digits I have. That's 3 digits. After the decimal there, that's 1 digit. This is how many? 4 digits. So the winner will be 1 digit after the decimal. maybe you like a real. Maybe we'll go for that. Let me get. Maybe it's better to have it on this. Stop. Stop sharing, and then share Microsoft Word with you. Now I can share with you I have 2.134. I'm adding 1.6, adding here 3.52. So now I said to myself, look at the digits, and I have to determine how many digits here we have after the decimal. 3. That's the decimal here for all of it. That's the decimal here. So I have 3 digits here, correct? I have 3 digits. I have here how many? 1 digit. I have here how many? The least of the digit will win. The least of the digit will win. So the least one is this one here. So whatever is my answer will be, I have to have the decimal after the decimal 1 digit. I cannot take 2 digits to 3. So calculate for me how much is this worth here. Will be the answer is here. What the answer is? This is 6, correct? And 6 and 5, 11, 11, 1, 12. This is 3 and 4 and 7. So the answer is this one here. From the calculator, after calculating, came out to be this one here. Okay, guys, now I have my answer says to me, I have to have the least digit after this one because I'm adding it. Or if I want to subtract, add addition, subtracting the same rules. It has 1 digit after this one. The 6 here is 1 digit after the decimal, correct? So then I have to stop here. I have to have 1 decimal, 1 digit after the decimal. However, this is 6 here before it, so it will go up 1. This 7.3. That's the correct answer, correct? 1 digit after decimal. So I have to take the 6 out. I have to take the 6 out because 2, 6, those 2 digits. I have to 6 out. Okay, guys, that's the answer. Now the same thing with this subtraction. The same thing with subtraction. Okay, guys. Now, how about multiplication and division? Multiplication and division. The multiplication and division is the same thing, but not with the digits this time. Not with the digit, but the same other rules. But we have to take the least significant figures. Okay, so addition and subtraction is the least digits after decimal to round when it comes to rounding, and the division and multiplication, the least significant figure. So let me go back and look at the so let's share this one here. Okay, guys. So when it comes to multiplication, for example. So you put your answer. So A, let's look at A. I'm multiplying, correct? Go on, multiply.
90.06.
90.06. Okay, 90.06. I have how many significant figures here? Here is 3, correct? That's multiplication and division is go by least number of sig figs to round. This is how many? 2, correct? 2 sig figs. So which will win? My answer has to be rounded to what? To the correct sig figs of what? Of 2, because that's the least one. See? This is the least one here. This is the most here. This is 3 sig figs, the other one 2 sig figs. So I have to make out of my what they call it, my answer. I have to round off to correct sig figs. This one will be 6. I have to have 2 sig figs, correct? So this one will go up as 1. So the answer is 91. The answer is 9 and 1. Okay, guys, 2 sig figs. Everyone's following? So let's do for me. I will wait for you. Do for me number C. C is challenging. Do for me C. See what will happen. Do for me C. I'll give you 1 minute. One minute, please. 1 minute. One minute to do.
0.8104.
Okay. And how many significant figures your answer will be rounded to?
2 significant.
That's correct. The least significant figures. This one is how many we say? 2 sig figs. This one how many?
4.
4. So the winner will be the 2. So you multiply, get your answer from the as is from the calculator, and then apply the rule of multiplication and division by least number of sig figs. The addition and subtraction by least number of the digits after the decimal. That's the difference between them. Okay. Let's look at the answers here now. Can you see the answers? 1 minute. I want you to go through those answers together to understand. So the first one is you said two significant figure W, and the answer is correct. Came 90, and then the author of this worksheet added decimal. So the 90 is 2 significant figures. That's correct because the decimal is present.
So, Professor, Dr. Atilla, do we have to always write 2 decimal places, or you will tell us?
Oh, it depends on the answer. If the answer requires from you to have this number of the fix in multiplication, and you don't have way to do it, then you have to add the decimal there. Sometimes to specify the number, you have to have you have to have adding zeros to satisfy the number of the rule, whatever rule you are using. Addition, multiplication, or division, multiplication. Addition, subtraction, multiplication. So, already looked at those? We are doing what? Least addition, multiplication and division is least significant figure. In the top here, all of those here, least digits after the decimal. And here, all those are the least significant. Here digits after decimal, the suffix. Or least significant. Okay, guys, so I wanted to do and practice a lot of other worksheets inside. And I think Dave sent you some of those worksheets as well. Now, before I conclude, I would like to have one more thing. It will be very interesting to know.
May you repeat it, please?
I will add another thing here. Just hold on. I will add another rule. So now, everybody can see this blank sheet. Everybody can see it.
Yes.
Yes.
Now, do for me
Yes.
this one here and tell me what's the answer here in this question here. Just I have 15.12. I have 13.6. I have 14.123. I have 3. So what's the answer? What's the correct answer first without rounding?
Is it multiplication?
Addition. This is addition. Watch.
It will be 42.84316.
42 point what?
84
84
316.
316. This is from the calculator now. What's the correct answer after we are applying the rule of addition and subtraction? We don't have subtraction here, but we have addition. So what? Because they are the same rules. What's the answer would be?
I think it would be 43.
3?
43.
Correct? Well,
Yes.
the answer is correct, 43, because you go by the digits, correct? So how many digits we have here? 2 after the decimal. This is the decimal here. Those are decimals. And this one, no decimal. This is 2, this is 1. This is how many? 3. This one how many?
0.
0. So which is the least digit will be? After decimal. No digits, correct? The answer is no digits, correct? The 0 digit. So 42, this is an 8. 5 and above, it has to be transferred into the 2 here. So the answer will be 3. And it has no decimal whatsoever, no decimal, because zero decimal, because that's the least digits after the, no digits after this one. So no digits, 43, that's the answer, that's it. Guys, make sense? Because here the least one is zero, that's the whole key. Zero means none. Just want to share with you. So that will cover the sig figs. I'll stop sharing now. I'll go for the PowerPoints. PowerPoints share. And we'll go for the PowerPoints share. Okay, I think we covered this one here. And as you can see, those are easy. We covered this one here in the sig figs, so we know this. We know the application of this, multiplication. We know this. This is the conversion. This type of conversion is very important. So I want to, whenever you are taking the quiz, the first quiz, the first exam, so make sure they make print out for this conversion. Nobody will ask you about memorizing all those conversions, but at least know how to do those conversions. Okay, guys, from metric to English, English to metric, and SI to metric, from SI to English, or to metric back. So you can, all this here will give you the opportunity to look at those conversions. Again, you are not allowed, you are allowed to use them, but you are not allowed to memorize them because you will be confused. Which one is which? I had memorized through the years. Too many of them, but still I got into this confusion about this conversion factors between those three systems: the English system, the metric system, and the SI system. SI stands for International System. So now we go for the materials, physical and chemical properties. What's the difference between physical and chemical properties? Well, the keyword is physical and chemical properties is reversibility. And we have physical change and chemical change, and we have physical and chemical property. The difference between them is the property is being observed and the change is carried out. Change is carried out. So the physical and chemical properties, the main thing is if you don't change any composition and you can recover this matter or material back or chemicals back, this is this will be a physical property of that chemical, of that compound. When you are not recovering this compound, and this compound is destroyed, and therefore you cannot recover it, this is a chemical property or change. Again, property is observed, and the change is carried out, change carried out. So that's the keyword. Now, the good thing is, let's go for go to the worksheet. So worksheets here. Open the worksheet for the physical versus chemical, so we can, okay. And then I will share that with you. Just let me see if I can. Okay, so we have a couple of those we can look into. Yes, we can look into this stop sharing. Now let me share the PDF file. Guys, if you look at this,
Question, do you have all your worksheets on iCollege?
Yeah, all the worksheets are in iCollege. All the worksheets in iCollege. I think this is the last topic in this chapter, and then we'll come back again if the time permits. We'll do the difference between precision and accuracy. But let us finish this one here. Glass breaking, the first one. What is this? Physical or chemical? Physical or chemical? Change or property? The word change, you have to carry this reaction. Physical reaction or chemical reaction. Property, observe, it's observation, then that's a property. So that's the difference. Property is not, it's just observe, and change is chemical, reaction with a physical or chemical reaction. So glass breaking is what? You have to put P or C. It's physical or chemical.
P is a P.
Physical, correct. Breaking a glass, you can bring this, melt the glass back and get it back again. So hammering a wood together, P or C? Come on, guys.
P is physical.
Physical, okay. Rusting bicycle. The word rusting means there is a chemical reaction going on, correct? Rusting bicycle, can you get this rusted bicycle back again? I doubt it. It will be taken apart, correct? So this is rusting a bicycle is a chemical, correct? Because you are going through irreversible process. You cannot recover your bike. It's already rusted. Melting butter
Is a P.
All the melting, boiling, evaporating, subliming, depositing, all this buoyant means temperatures, and the temperature is a physical property of the matter itself. The same thing like density, same thing like refractive index. All those are physical properties of the matter itself. So separate. Let's do the finish. 5. I'll say 5. The number you tell me is whether
Physical.
It's okay, separate sign from it. It's physical. Bleaching your hair
Is a C.
It's a chemical. Frying an egg. Frying an egg.
Chemical.
It's
No,
a chemical frying. That's combustion because you are combusting your egg. So you cannot retrieve your egg back. It's gone. When you fry it, it's gone. So you let it. It's a chemical reaction between oxygen and part of the egg. So part of the egg will be combusted. Squeeze orange for juice. Or squeeze oranges for juice.
Physical.
Melting ice. Again, every time I have melting, boiling, whatever, subliming, all those are
physical.
that's a physical process. Yes. Mixing salt and tap water.
Is a physical.
Mixing oil and tap water. This is what? Physical, because that's just, again, because you can separate them out and there is no change in their composition. You are not getting them composed or changing their decomposition. You just put them together physically and get them out physically. Water evaporating, all the melting, freezing, evaporating, boiling, subliming, depositing, condensating, temperatures or points, those are physical. So water evaporating is physical. Cutting grass, the grass will come back again, even if you cut it 100,000 times. So that's physical, it's come back again. Burning leaves, that's different. Burning, anytime with burning, cooking, that's a chemical. And it started cooking, burning, bleaching, all those rusting, those are chemical change, chemical reaction going on there. Fireworks exploding.
Is a chemical.
Chemical because you are exposing those salts to higher temperature. You are doing like you are combusting those salts. Literally, because they will react with the tremendous heat. That's enough to break them into pieces. Okay, so cutting your hair,
Is a physical.
crashing a can,
Is a physical.
boiling tamar,
Is a physical too.
all those physical. So that's and then you can see all the top here. If you look at the top here, and you can look, all these are physical, some of them physical properties, some of them are chemical. Anytime with points means temperature, that has to be physical. So I think time up. Yeah, the time is up. I'll stop here the recording and we'll come back. We'll look at the last topic, which is the accuracy and density, accuracy, precision, and then we'll do for density, temperature, and then we'll be done for chapter 1. I hope that's, I hope this Thursday we come back to school. And tomorrow we don't know, just keep watching the weather at the GSU website. If the school will close tomorrow, they will let us know. If they will open tomorrow will be classes. Thank you very much. Thank you. Okay, any question you have? Any question, guys? No question, I'll stop here, okay? I'll stop
No,
recording.
thank you. Have a great day.
You too, thank you.